Welcome to lectures on instrumentation in process industries. So we have discussed thermal power plant and the instrumentation involved employed in the thermal power plant. We have discussed temperature measurement, pressure, flow measurement, how different parameters are to be measured. We have discussed. In this class, we introduce petrochemical plant. So the objective of this lesson is we see the layout of petrochemical plant and we explain the process based on the layout of petrochemical plant and important chemicals and their uses we discuss and we discuss the units of petrochemical plant and defining thermal cracking, catalytic cracking, polymerization, alkalization, isomerization, and explain the process of thermal cracking and fluid catalytic cracking. And we see the byproducts of crude oil and the distillation column working and its PI diagram. And what are the physical parameters we have to measure in the PCP, petrochemical plant? We discuss and the flow, pressure, and density of uh, different fluids in the petrochemical plant. We'll discuss and we discuss the centrifugal pump used in the petrochemical plant and we discuss the safety measures we have to consider in handling petrochemicals. And what are the petrochemicals? So, the petrochemicals are chemicals derived from petroleum products. So, for examples, plastics, rubbers, fibers, paints, solvents, and detergents. And these are the examples of petrochemicals usage, how these materials are manufactured with the petrochemicals. Petrochemicals plays important role in manufacturing these items. And in fact, petroleum products are a mixture of hydrocarbons, whereas the raw materials for petrochemicals are pure hydrocarbons separated and converted to desirable products such as polymers, solvents, and surfactants and fibers, paints, solvents, and like this. You see, the petrochemicals are pure hydrocarbons that we have to remember. And these hydrocarbons are available from the natural and oil gas industry. And these hydrocarbons, heavy hydrocarbons, are fractioned and separated each element. Uh, so those elements are called petrochemicals. So the petrochemicals may be grouped as broadly you can classify into three. And the first generation petrochemicals are feedstocks. Here, uh, the these feedstocks are used by the second generation petrochemicals, that is intermediates. So the intermediates takes these feedstocks and gives us the finished products. Here, the finished products are third generation petrochemicals end use products. So, these are the petrochemicals grouping. And if you observe here, this is the layout we can discuss. Here, this is the petroleum industry. This section is the petroleum industry. The crude oil is available, which is available from the earth, is now feed into the oil refining facilities. So, oil refining. So, the oil refining is the refining process in which crude oil is processed and different elements are produced. So, for example, naphtha, here naphtha and gases, gases and reformates. So, these are the different types of products produced by oil refining section. And mostly this naphtha plays important role. Most of 60 to 70% of petrochemicals are derived from the naphtha. Here the naphtha is taken, and here we have the important section. Here we have this section. This section is petrochemical industry. So the petrochemical industry involves steam cracking and dehydrogenation process. So these are the facilities of the petrochemical plant. It takes the raw materials, input raw materials, the petrochemical plant or industry will take the raw materials, naphtha. So this is the naphtha, which is the raw material for the petrochemical industry, and some heavy gases. So these are the raw materials available to the petrochemical industry. So after cracking these naphtha and other outputs of oil refining petroleum industry, then we'll get after cracking you will get the ethylene and ethylene derivatives and propylene and propylene derivatives and C4 C5 fractions and C4 C5 derivatives and aromatic fractions and aromatic derivatives. So these are the petrochemicals available after cracking. So the petrochemical in the petrochemical industry, steam cracking plays important role, which will fraction the naphtha input raw material into different fractional elements like ethylene, propylene, C4, C5 fraction, aromatic fractions. So which are the first stage, that means first generation products. So these products are used to generate second generation products, intermediate products. After intermediate products, we have final products. Okay, now, so this is the flow diagram of atmospheric and vacuum distillation units and heat exchangers and desalter and heaters, distillation columns and overhead condensers, pump and around streams, vacuum distillation heater and vacuum tower. If you observe, so this is a crude oil we have. So this is the oil and natural gas industry in which the crude oil is taken as the raw material here. The crude oil is processed like this by sending through different series of heat exchangers and condensers and distillation. This is the atmospheric distillation column, and next series of pumps here, steam pumps, and at various columns the steam is collected at different fractional elements as a different fractional elements. Here vacuum tower is here, distillation column where we have different types of materials available to us. So this is the oil refinery section in which we have the heavy carbon elements as outputs and some useful kerosene, diesel, petroleum products, and light naphtha and heavy naphtha, and some gases. So these are the different elements available at the output of oil and natural gas refining section. So to the these are the inputs to the petrochemical plant. And if you see, there are different units here, and you have the 1 and 3 are heat exchangers, and 2 is the item 2 is the desalter, and 3 4 are the heaters, and the fifth one is the distillation column, atmospheric distillation column, and the sixth one is the condenser, and 7 to 10 are pump around streams, and 11th one is the heater, vacuum distillation heater, and 12th one is the vacuum tower. So this is a island natural gas refining system we have. And now let us consider the feedstocks. Here, this is the actual layout of the we have seen in the second diagram. We have seen this oil refining facility, petroleum industry. uh, Naphtha is available from the petroleum industry, and this is used as a raw material for the petrochemical plant here, where the steam cracking is done, so to produce the petrochemicals, these petrochemicals, and it produces first the basic petrochemicals here. Those are the feedstocks. So feedstocks are the raw hydrocarbons obtained from crude oil refining by distillation and thermal catalytic processes. For instance, hydrocarbon gases and naphtha are available from atmospheric distillation of crude oil that we have seen just now. So these raw hydrocarbons, which are called as naphtha, for example, it is treated as a raw hydrocarbon, so which is subjected to the cracking. Similarly, we have benzene, toluene, xylene obtained by catalytic reforming and catalytic cracking processes are the major raw materials for the manufacture of second generation petrochemicals. And benzene, toluene, xylene, and heavier aromatics are also generated as byproducts from petrochemical plants. Thus, the feedstocks for petrochemical plants are either directly obtained from refineries or, or further processed to generate them in the petrochemical plant itself. So that is the idea. That means the feedstocks are received from the oil and natural gas refinery system, and sometimes they can be also generated within the petrochemical plant itself. And natural gas and refinery products are the major source of feedstocks for petrochemicals. Now, let us see the intermediates. So, now in this, the thermal cracking of ethane, propane, butane, and naphtha produces cracked gases or olefins, that is ethylene, propylene, butylene, acetylene, etc., and liquids such as benzene, toluenes. So, the thermal cracking of the naphtha or ethane, propane, butane, what it produces, and let us see here the crude oil is used as a fuel for transportation and power generation and power supply. You see, observe here the crude oil is processed and output of after refining. Here we have the intermediate products available after distillation of these feedstocks. We have the methane, ethane, and propane, butane, benzene, etc. And these are the items, intermediates, and alcohols, and carboxylic acids, amines, and ethers, and aldehydes, halogen derivatives like this. These are all intermediates. And these intermediate products are once again processed and fractioned into these final products. So these are make use of these. With the help of these intermediates, we manufacture the final products, that is solvents, polymers, fertilizers, pesticides, detergents, dyes, cosmetics, etc. So, and that means now next, with the help of these items, we can generate, we can manufacture clothing, shelter, food, health, transportation, and communication. That means without petrochemicals, we can't live. That is the in everywhere the petrochemicals are used. That is clothing purpose and for the in the construction field, in the food items, and in the health and medical infrastructures, and the transportation systems and communication. Everywhere these petrochemicals are used. Hence, they play important role in our lives. And these finished products using the above intermediates, a variety of plastics, rubber, fiber, solvent, paint, etc., are manufactured, and polymerization reactions are carried out for these monomers or intermediates to various polymers, resinous, and liquid products. And the plastics are available in the form of extrudates, granules, and powders, buds, etc., from the manufacturing units as the finished products. So, now let us see the basic feedstocks and intermediates in a table. So, here, if you observe, basic feedstocks are benzene, butadiene, ethylene, and pixylene and propylene. And these are the basic feedstock. And we have the intermediates, that is uh, ethyl hexol, acetic acid, acrylonitrite, and N-butane, cyclohexane, and dimethyl terephthalate, and benzene, and ethanol, ethanolamine, ethanoxylate, and these are all the intermediates we have the products. After intermediates, we have the fibers. Here, acrylic fiber and acrylonite, uh, butadiene, and styrene. That is the ABS. ABS is the acrylonite and butadiene and styrene. And acrylonitrile styrene AS and polybutadiene PBR. So next polyvinyl chloride PVC and polyethylene PE and polyethylene terephthalate, that is PET, and polyol polypropylene, that is the PP, and polystyrene is the PS, and styrene butadiene is the SBR, and acrylic formaldehyde and AF. So these are the fibers available from the petrochemicals. And petroleum products are the lubricants, additives, catalysts, and marine fuel, oil, petroleum refining. So next the chemicals are adhesives, sealants, agrochemicals, construction chemicals, corrosion control chemicals, cosmetic raw materials, electronic chemicals and materials, and flavorings, fragrances, food additives, pharmaceutical drugs, specialty and industrial chemicals, specialty and industrial gases, inks, dyes, printing supplies, packaging, bottles and containers, paint, coating, resins, polymer additives, specialty and life sciences chemicals, and surfactants and cleaning agents. So these are the chemicals. Now let us see the important petrochemicals and their uses. Already you see the uses here we have listed down. These are the uses in clothing, shelter, food, health, transportation, and communication, agricultural. So these are the uses of petrochemicals in day-to-day life. Here, the petrochemicals are here we have methane, ethane, ethene, propane, butane, and benzene, and alcohols, amines. Out of these, we have the after processing we have the final products, solvents, polymers, fertilizers, and pesticides. and detergents, dyes, and cosmetics, which are widely used. And not only that, these products also can be useful in clothing, that is polyester cloths, and shelter, that is construction materials, can be manufactured out of these, and food items also can be manufactured with the help of these, and the medical and health sector also make use of all these elements in the transportation and communication also. So the units available in petrochemical plant: main process units and their functions in oil refineries and petrochemical plants are described. Among them are atmospheric and vacuum crude distillation. So this is the unit which is widely used in refineries, oil refineries, and fluid catalytic cracking and hydro cracking. These are the important cracking techniques which are used in petrochemical industry, and hydroprocessing including hydro desulfurization and catalytic reforming, continuous catalytic regeneration, and isomerization units. So these are the units available in the petrochemical plant, and we have the supporting units also. So these are the amine treating, sulfur recovery, tail gas treatment, sour water stripper, and wastewater facilities. So these are the supporting units. Now let us see the thermal cracking. So this is the important process in chemical petrochemical industry. So cracking is an extraction process in which hydrocarbons such as crude oil are heated to a high temperature to break the molecules. So the thermal cracking is a refining process in which heat and pressure are used to break down, rearrange or combine hydrocarbon molecules. So this is the thermal cracking process. So the majority of thermal cracking processes uses the temperature 455 degrees centigrade to 540 degrees centigrade, that is 850 degree Fahrenheit to 1005 degree Fahrenheit, and the pressures up to 1000 psi, from 100 to 1000 psi pressures are also employed in this. The dubs process may be taken as a typical application of a early thermal cracking operation. And now let us see the catalytic cracking. The reduction of the molecular weight of hydrocarbons by a catalyst accomplished in a petroleum refinery by a type of chemical reactor, that is the catalytic cracker. So with the help of this, with the catalyst, the molecular weight of hydrocarbons are reduced, and here the fluid catalytic cracking, that is the FCC, is one of the most important conversion processes used in petroleum refineries. It is widely used to convert the high boiling, high molecular weight hydrocarbon fractions of petroleum crude oil into more valuable gasoline, olefinic gases, and other products. And here, observe here, the catalytic cracker plays important role, which will take the crude oil and which will reduce the rudile into different usable petrochemicals by utilizing the catalyst as a boost parameter element, chemical element, which will which will efficiently crack the hydrocarbons into different useful gases. These gasoline products, olefinic products, are very important and have high demand in manufacturing plastics. And this FCC, it will convert hydrocarbons into the fractions of these two important or other important fractions also. So now let us see the polymerization. So polymerization is the process of converting a monomer or a mixture of monomers into a polymer like this. If you observe here, the monomer is here. This is the monomer. It is the styrene, and this monomer, it has a double bond like this. You see CH2. After polymerization, what happens is this has become a single bond here. So that is CH2, CH2 like that. So this polystyrene is manufactured with, by the styrene, which is subjected to polymerization. So this polystyrene used in cloths, manufacturing cloths. The next important parameter is alkalization. So here, this is a process that lowers the amount of acid in a solution. In medicine, an alkali as a sodium bicarbonate may be given to patients to lower high levels of acid in the blood or urine that can be caused by certain medicines or conditions. So this is a alkaline which will play important role in decreasing the acidic content in the body. So the next important process is isomerization. Here, so this is the process by which one molecule is transformed into another molecule which has exactly the same atoms, but the atoms have a different arrangement. For example, atoms ABC are arranged in the sequence of ABC. And if you do isomerization, what do we get is BAC. So hence these are called isomers. These two items are called isomers. This is one isomer, this is another isomer because they are related with molecules. So observe here, this is the isomer. Both are isomers if you observe. So the vinyl norborman gives the commercially important monomer ethylene narbomen. Ethylene, ethylene narbomen. If you observe here, this is one monomer and this is another monomer. So approximately, if you see here and that is here, you see the difference. So the molecular arrangement is transformed like that. So the bonding here is transformed into here, so that a different molecule is formed. And now let us see the thermal cracking here. The thermal cracking is an extraction process in which the hydrocarbons such as crude oil are heated to a high temperature to break the molecular bonds. Thermal cracking is a refining process in which heat pressure are used to break down, rearrange and combine hydrocarbon molecules. So this is the importance of thermal cracking. Here, so the thermal cracking plays important role in converting the heavy hydrocarbons into useful products, that is petrochemicals. So the majority of thermal cracking processes use the temperatures of 455 degrees centigrade to 550 40 degrees centigrade. In Fahrenheit it is 850 to 1005. So the pressures approximately from 100 to 1000 psi is applicable here. And mostly in the early thermal cracking technique was Dubs process, so in which the heavy molecules are converted into lighter molecules, useful molecules, that is the petrochemicals. In the process, the feedstock, that is the refused crude, is preheated by direct exchange with the cracking products in the fractioning columns. So the cracked gasoline and the heating oil are removed from the upper section of the column. And light and heavy distillate fractions are removed from the lower section and are pumped to separate heaters. So this is the thermal cracking process. High temperatures are used to crack the more refractory light distillate fractions. So that is the high temperatures are maintained to crack more refractory light distillate fractions. The product streams from the heaters are combined and sent to a soaking chamber where they remain for an additional time period to complete the cracking reactions. That means the streams from the heaters are combined in soaking chamber, so that the sufficient time is taken here for the efficient cracking of the product. So the cracked products are then separated in a low pressure flash chamber where a heavy fuel oil is removed as the bottom's product. So these products are separated in a low pressure flash chamber, and so that the heavy fuels are removed at the bottom side. So the remaining cracked products are sent to the fractionating columns, that is the fractional distillation column. So with this, we can conclude our lesson. And in this class, we have discussed the general layout of a petrochemical plant, in which we have seen the refining section, petroleum section, and here next we have seen petrochemical plant, and we have discussed the process based upon that layout, how the petroleum products are used to produce petrochemicals, and we have seen the important petrochemicals and their usages, and we have studied the units in petrochemical plant, that is unit operations, that is thermal cracking, catalytic cracking, polymerization, alkalization, isomerization, and we have discussed in detail the process of thermal cracking, and in that how different materials or feedstock are subjected to different temperature and pressure conditions, so that the lighter molecules are collected at the top and heavier molecules are collected at the bottom. So these are the important units in petrochemical plant, that is atmospheric and vacuum crude distillation columns. Here, the atmospheric will produce us the naphtha and its derivatives like that, and vacuum crude distillation, different gases it produces, and these are subjected to chemical industry, used as a feedstock in chemical industry, and then in the chemical industry we say the fluid catalytic cracking and hydrocracking and hydroprocessing, including hydro desulfurization and catalytic reforming, continuous catalytic regeneration, and isomerization units. So these are the units that play important role in petrochemical plant to separate different elements from the major hydrocarbons. Here, what we have to consider is for the crude oil is subjected to uh, distillation column, atmospheric distillation column. That is here, for example, here is the atmospheric distillation column, which is maintaining different temperatures as you descend from top to bottom. Then what happens is this crude oil which is pumped into the atmospheric distillation column produces the methane, ethane, and propane, butane, benzene, like that, naphtha, like that products. So which are once again cracked with the help of FCC, fluid catalytic cracking method, so that we have the final products. With the final products, we develop the basic needs. Here, if you observe, the final products are the solvents, polymers, fertilizers, pesticides, detergents, and dyes and cosmetics, which are widely used in our daily life. And the basic needs out of these, we can manufacture different cloths, that is polyester cloth, and like that. And we can design the uh, different materials can be used in the construction design. And not only that, some of the petrochemicals are used in food items and health and medicine sector and transportation. In the transportation also, these products are used. And in the communication, that is manufacturing the devices, communication devices. So the basic needs are fulfilled like this. So with this, we conclude our lesson. We will discuss in the next class FCC and different instrumentation employed in the measurement of different parameters in petrochemical plants.